Namaste bachcho. Today we are going to discuss another topic related to class 10th in mathematics. Now your first chapter is going on. The chapter name is real number. This is the part 5 of real number. We have already discussed about irrational numbers. Now we have to discuss again the irrational numbers. There was a philosopher named Hippocrates. Hippocrates, a great philosopher, was credited with the discovery of irrational numbers. As you can see here, I have written Hippocrates, a great philosopher, was credited with the discovery of irrational numbers. He was a member of a group called Pythagorean mathematicians. वो एक सदस्य थे पाइथागोरियन मैथमेटिशियन की. He proved that he exists for Hippocrates. He proved the existence of the irrational number √2 by the method of contradiction. He was the person who had proved that √2 is an irrational number by the method of contradiction. As we know that irrational numbers cannot be represented in the form of p by q. As we have already discussed about irrational numbers, so we know that an irrational number can't be represented as or can't be expressed as in the form of p by q, where q not equal to 0 and p and q are integers. Some examples of irrational numbers are, we have written here, √2, √3, √5, √6, √7, √8, √10, √11 and extra. All these numbers within the root are non-perfect squares. 2 is non-perfect square, 3 is non-perfect square, 5 is non-perfect square, 6 is also non-perfect square. So, and all the non-perfect square numbers taken together and their square root will be irrational. If we have a square root of a non-perfect square, then the number so obtained will be an irrational number. As you can see, 2 is not a perfect square, so their square root is irrational. 3 is not a perfect square, so the square root of 3 is irrational. And 5 is also not a perfect number, so root 5 is irrational. Similarly, these numbers are irrational. Now we will prove that √2 is an irrational number by the method of contradiction. As the Hippocrates has proved that √2 is an irrational number by the method of contradiction, so we can also prove that √2, √3, √5, √6, √7, √8, √10, √11 and any other non-perfect number, the square root of any non-perfect number, we can prove that these are irrational numbers. So let us prove it. We will prove it by the method of contradiction. Okay, so let us try it. Now, first of all, we will know that what are method of contradiction. The method of contradiction. The method of contradiction. First of all, we will discuss what is the method of contradiction. So, there are two parts. First, assume. Assume means suppose the statement to be false. The statement that has to be proved, the statement to be false. Which statement? The statement which is to be proved. Suppose we have to prove that what? Root 2 is irrational. Then we will assume that the given statement is false. Then conclude our assumption is wrong. Assumption is wrong by contradiction. Then we will conclude that our assumption is wrong by the method of contradiction. So first of all, assume that the statement that has to be proved is false, and then conclude that the assumption whatever we have assumed is wrong by contradiction. Let us see an example. For example, suppose the statement is given. The statement is 2 is an even number. The statement is given 2 is an even number. As we know that 2 is an even number. So the statement is given 2 is an even number. So assumption 2 is not an even number. So what you will suppose? You will suppose that 2 is not an even number. The statement is given 2 is an even number. So assume that 2 is not an even number. The statement is false. So how it will be false? Then you have to suppose 2 is not an even number. 2 is not an even number. So 2 is not an even number. This implies that 2 is not divisible by 2. So we have supposed that 2 is not an even number. That means 2 is not divisible by 2. So by contradiction, 2 is an even number. If we will suppose that 2 is not an even number, that means 2 is not divisible by 2. And if 2 is not divisible by 2, that is, the contradiction arises. As we know that 2 is exactly divisible by 2. So the contradiction arises here. 2 is an even number. So our supposition is wrong, and hence we can say that 2 is divisible by 2, hence 2 is an even number. So this is a short example of the method of contradiction. Now we will prove that root 2 is an irrational number. So how to prove it? Let us see. We have to prove that Similarly, you can prove that root 2, root 3, root 5, root 7, root 6, root 7, root 8, root 10, root 11. Similarly, you can prove it. These numbers are irrational. So we have to prove that root 2 is an irrational number. So let us first suppose that root 2 is not an irrational number. Then what we will suppose? We have to suppose that root 2 is a rational number. So let us consider or assume that root 2 is a rational number. We have assumed that root 2 is a rational number, and we know that every rational number can be expressed is in the form of p by q. As we know that every rational number can be expressed as in the form of p by q, where q is not equal to 0. Here p and q are in their lowest form, having no common factor other than 1. That is, p and q are in its simplest form, and simplest form, that means if it is in lowest form or simplest form, then there will be no common factor other than 1. So root 2 can be written as what? P by q. Now cross multiply it. Just cross multiply it. Root 2 multiplied by q and p multiplied by 1. So the p will become root 2 q. Now squaring on both sides. We get p square will be 2q square. That is, p square is a multiple of 2 multiplied by q square. You can also write it 2 multiplied by q square. So this implies that p square is a factor of 2 is a factor of q square. P square. P square. This implies that 2 is a factor of p also. If the square of a number is a factor of any number, then its square root will be also a factor of that number. So 2 is a factor of what? 2 is a factor of p square. If we divide it by 2, then it will be equal to q square. So 2 is a factor of p square. Then 2 is also a factor of p. Now since 2 is a factor of p, so let p is equal to 2m, where m is some integer. So p is equal to 2m, and let us suppose it equation second, and let us suppose it this one is first. Now put the value of p in equation first. Putting p is equal to 2m in first. So what we will get? We will get that the 2m the whole square, since p square is here, so put p is equal to 2m. So put p is equal to 2m, then 2m and the whole square will be equal to 2q square. This implies that 2q square will be, the square of 2 is 4 and the square of m is m square. Then cancel the 4 by 2, it will become 2q square is equal to 2m square. Here is the same result we have got. P square is equal to 2q square and here q square is equal to 2m square. This implies that q square is a factor of q square. This implies that, 2 is a factor of q square. This implies that 2 is a factor of q also, and then let q is equal to 2n for some integer n, and this is equation third. So from equation second and third we get p is equal to, p by q is equal to 2n by 2n. Now look here carefully. What we have supposed? We have supposed that the p and q are in their lowest form, having no common factor other than 1. We have supposed that p and q are in lowest form and having no common factor other than 1. But what we see here, see the 2 is common factor of both p and q. So 2 is the common factor of both p and q. So both p and q have been common factor 2, and this is a contradiction. Contradiction to our assumption that p and q having no common factor other than 1. As we have supposed, assume that p and q having no common factor other than 1. But here we can see that both p and q are having common factor 2, which is other than 1. So the contradiction arises. So we have to write that, now we will write that the contradiction arises by assuming that root 2 is irrational. Hence, root 2 is an irrational number. Similarly, you can prove that. Now this is the assignment for you. Prove that. This is the assignment for you. As like root 2, you can prove that. Prove that all the numbers given below are irrational. The first one is root 3, second one is root 5. This is the most important question for your examination point of view. In this year, also a question has arrived from this, that prove that root 2 is irrational, or prove that root 3 is irrational, or prove that root 5 is irrational. One question arises in every year. So let us try to by your own to prove that root 3 is irrational, root 5 is irrational. Similarly, 3 root 6 is irrational, 4 root 7 is irrational, 5 root 11 is irrational. And you can also prove that root 6 is also irrational. So this is the assignment for you. Okay, have a nice day.